Hello learners, today we are going to learn one sample t-test. So basically one sample t-test is a part of inferential statistics. In this we are trying to infer population from the given samples. So let's check one caselet of Bolu industry. So Bolu industry basically manufactures LED bulbs and that claims that the lamps manufactured from Bolu industry has a lifespan of 12,000 hours. So now we have population mean that is 12,000 hours. Now quality assurance team wants to check whether the claim is correct or not. So those they select 30 samples and they check the lifespans of the bulbs. So here there is a data of 30 lamps and the different lifespans. So now if you check here, we just need to see whether that they achieve the standard or not. So we can have a descriptive statistics or we can have a mean of these 30 bulbs and that is nearly 11,908. So from here only we can say that yes, the claim is not made, but still I want a statistical proof, and that's why I will go with t-test. Now when I apply t-test, there are some assumptions. The first assumption is data should be randomly selected. The second assumption is data should be normally distributed. So for checking the normality, we first plot histogram. So you can check the histogram. It is showing some characteristics of normality. If I make here mean, the data is distributed or making a kind of a bell shape. But still, we need to check statistically. So let's load the data in SPSS and move further. So I am opening SPSS. I am opening the file Excel. Okay. So when you load the data, you check in a preview file or preview tab and just hit OK. So I have the data of 30 samples. Now I need to check whether the data is normal or not. So for that, I will click on Analyze. I will click on Descriptive Statistics. I will click on Explore. I will enter this lifespan. I will click on Plots. I will activate this tab Normality Plots with Test. I will continue. I will just hit OK. I will get the basic summary, basic descriptives, and here I have a test of normality. You need to see this p-value. Here the p-value is 0.685. Let's copy it. Here the p-value is 0.675. So now if I just see the hypothesis of normality. So here null hypothesis states that data is normally distributed and alternate states that data is not normally distributed. And here the game of p-value starts. If the p-value is more than 0.05, we can say that we fail to reject the null hypothesis. In other words, our null hypothesis is correct. So here p-value is more than 0.05. So our null hypothesis is data is normally distributed. And so we say that yes, data is normally distributed. Okay, so first step for doing the t-test is clear. Now moving towards the second step, running the t-test. So just click on the analyze menu, go to compare me, click on one sample t-test. You can see the test variables, just load the lifespan hours in it or test variable here. You can see here test value. Here you need to enter population mean. So here 12,000 is our population mean. When I just hit OK, You can see the three things. The first is sample statistics, where you see the sample mean, that is 11,905. You can see here two tail, where two tail it is showing the p value, that is less than 0.05. So here we will just write here p value is less than 0.05, that is 0. Let's check the hypothesis. So here null hypothesis states that mu is equal to 12,000 and alternate states that mu is not equal to 12,000. So here yes, p value is 0, that is less than 0.05. So we reject the null hypothesis and we go with alternate hypothesis that states that population mean and sample mean is not equal. So the claim of population mean, that is 12,000, that a lamp coming out from the factory of Bolu industry, which is giving a lifespan of 12,000, the claim is not correct. It is less than that. Now moving towards more important, effect size. You can see here the one sample effect size. Here your point estimate shows the negative 0.836. Now this has a kind of impact. Like if I am saying that does this claim, what is the difference, what is the effect size of the sample? So whether the effect is more or less. So we have a kind of a sheet that says that whether the effect size is more or less. So suppose your answer comes between 0 to 0.2, the effect is negligible. The difference is so small that virtually invisible, and that is acceptable. When it comes from zero point 0.2 to zero point 0.5, defect is your effect is minor. It requires statistical power to notice, but when the effect size is increased from zero point 0.5 to zero point 0.8 or zero point 0.8 to 1.2, the effect size is noticeable. So our effect size was 0.845. So here we can say that the difference is more. The claim was 12,000, but actual mean from the sample was nearly 900, and you can say kind of 11,905. So from 12,000 to 11,905 there is more deviation, and that can be seen from here. So this way we need to interpret one sample t-test. So now always remember, if you are working with one sample t-test, you need to first check the normality. If the normality is there in a data, you go with one sample t-test. But if normality is not there, if the normality is not there, there is another statistical test known as Wilcoxon signed rank test that will be attached in next video. So thank you.